You woke up early. You skipped breakfast. You bought the expensive supplements. You even forced yourself through another fasting window. And somehow, you still feel older. Not because you're lazy, not because you lacked discipline. Your body may have been protecting itself in a way nobody ever explained to you. Most people believe aging begins when wrinkles appear or energy disappears. But what if the real damage started years earlier, inside your cells, long before you noticed anything? And what if one tiny biological structure has been silently deciding how long those cells can keep repairing themselves? Stay with me, because this changes everything. You've probably had that frustrating moment. You clean up your diet. You lose a little weight. Your energy improves for a few weeks. Then everything slows down again. Recovery takes longer. Sleep doesn't refresh you the same way. Small injuries linger. Your body feels like it's running an older version of itself. That feeling isn't imaginary. And it wasn't a lack of discipline. Your body was responding exactly as it was designed to. Here's the critical thing to understand. Imagine every cell in your body as a construction crew, rebuilding the same house every single day. Each repair is careful. Each copy is almost perfect. But every time the blueprint is photocopied, one tiny corner gets cut away. At first, it doesn't matter. Then another corner disappears. Then another. Eventually, the blueprint becomes too damaged to build from anymore. That's remarkably similar to what happens inside your chromosomes. At the ends of every chromosome sit protective caps called telomeres. Think of them as the plastic tips on shoelaces. Their job is simple. Protect the genetic information during every cell division. But every division makes those caps slightly shorter. Most people never realize this. Your body isn't simply getting older. It's slowly running out of protective margins. And here's where everything changes. Years ago, researchers studying tiny organisms noticed something strange. Certain cells seemed to ignore this countdown. They kept dividing far longer than expected. That mystery eventually led scientists toward an extraordinary enzyme called telomerase. The discovery became one of the biggest breakthroughs in cellular biology, with pioneering work by Elizabeth Blackburn and her colleagues earning global recognition. Suddenly, aging wasn't just about time. It was about maintenance. I know, that sounds strange, because we've spent decades believing aging is simply unavoidable. But here's the part nobody talks about. Your body actually knows how to protect these chromosome ends. The problem isn't that the repair system never existed. The problem is that most of your everyday biology tells it to stay quiet. Here's what most people completely miss. Think of telomerase as a highly skilled repair technician locked inside a workshop. The technician isn't gone. The tools aren't broken. The workshop door simply isn't being opened very often. Why? Because your cells constantly read signals from their environment. They ask one question over and over. Is this a safe time to invest in repair? Or, is survival more important? That decision changes everything. Researchers at institutions like Salk Institute have spent years exploring how nutrient, sensing, cellular stress, and repair pathways influence healthy aging. One pathway appears again and again: AMPK. Think of AMPK as the city's emergency energy manager. When energy becomes scarce, but not dangerously scarce, it begins redirecting resources away from waste and toward repair. That's one reason carefully timed fasting has attracted so much scientific attention. Not because fasting is magic, because your cells interpret temporary energy shortage as valuable information. But here's the surprising part. Many people copy fasting routines from social media and accidentally create the opposite effect. Their bodies experience stress without enough recovery. Their repair crews never catch up. Their cells remain cautious. Their biology keeps postponing maintenance. And that's where everything changes. Because activating the right repair pathways isn't only about eating less, it's about sending the correct sequence of biological signals. Signals that influence whether your cells stay in survival mode or cautiously begin investing in long-term maintenance again. And hidden inside that sequence is one overlooked factor that can quietly shut the entire process down, even in people doing almost everything right. Here's the part nobody talks about. The quiet villain isn't simply sugar. It isn't carbohydrates. It isn't even aging itself. It's chronically elevated insulin, not the healthy rise after a balanced meal. The constant signal that tells your cells resources are always available, yet somehow never safe enough to prioritize deep repair. Imagine a factory that receives non-stop orders for new production. The machines never stop making products. Nobody has time to service the equipment. Small cracks become larger ones. Eventually, production slows, not because the workers became lazy, but because maintenance never happened. Your cells behave in a surprisingly similar way. Persistently high insulin keeps pushing growth-related pathways like mTOR. Growth has its place. You need it for muscle, healing, and immune function. But when growth stays switched on all day, your cells delay many repair programs that normally work behind the scenes. That's the blind spot. Most people thought they needed more stimulation. Their cells actually needed better timing. What happened next surprised researchers. Studies exploring healthy aging found that it's often the rhythm of metabolic signals, not constant restriction, that creates an environment where repair pathways become more active. Your biology responds to patterns, not perfection. Stay with me. This is the part that matters. Start your morning with protein instead of refined sugar. Eggs, plain Greek yogurt, or tofu with vegetables are excellent choices. Why? Protein helps stabilize blood sugar and reduces large insulin spikes that can echo throughout the day. Mid-morning, step outside for a brisk 20 to 30-minute walk. Not because walking burns huge numbers of calories, because contracting muscles naturally activate AMPK, giving your cells another gentle signal that energy should be managed efficiently instead of wasted. At lunch, build your plate around colorful vegetables, healthy fats like olive oil, and a moderate portion of fish, beans, or chicken. The fiber slows glucose absorption. The healthy fats improve satiety. Your body receives a steadier metabolic message instead of another sharp wave of insulin. Here's where it gets counterintuitive. Don't chase endless fasting. Finish dinner 2 to 3 hours before bed instead. That overnight window gives your cells time to shift away from constant digestion while protecting sleep quality. Better sleep lowers unnecessary cortisol, another hormone that can interfere with healthy cellular repair when it remains elevated. In the evening, keep bright screens low and prioritize 7 to 9 hours of consistent sleep. Why? Many of your repair systems, including DNA maintenance, perform their most important work while you're asleep. You aren't simply resting, you're rebuilding. And remember something important. None of these habits directly switch on telomerase like flipping a light switch. Human biology is far more complex than that. But together, they help create the metabolic environment associated with healthier cellular maintenance and resilience. That's how longevity works. Not through one miracle supplement, not through one extreme fast. Small signal, small repair, repeated thousands of times. Your body notices. Your cells notice. And over months and years, those tiny biological decisions begin compounding into a very different future. The remarkable part is that your body has been trying to protect you all along. Once you understand its language, you stop fighting your biology and start working with it. But here's the question almost nobody asks. If telomeres help determine how long cells can divide, what decides whether those cells act young or old, even when the DNA stays the same? The answer lies in epigenetics, a hidden biological control system that can silence youth without changing your genes. And once you see how that system works, you'll never look at aging the same way again.